Here we have an integral from 0 to 1 of x cosine x cubed dx, and we want it accurate to 3 decimal places. So you ever have those moments where you're like, oh, I really want to evaluate this integral, but it does not use subbable. It's not really able to be evaluated by any of our other strategies. And so this time we are actually going to use series, specifically a Taylor series, Maclaurin series, to approximate this definite integral. It's not going to give us an exact answer, but it'll do a good job. So what we first want to do is the integral from 0 to 1 of x times. Now I want to do the polynomial expansion. The reason I'm doing this is because polynomials are much easier to integrate than cosine x cubed of x cubed. So cosine's an even function. Notice, so that's why I've got 2 there. But instead of having x on the inside, I'm going to have x cubed on the inside because that's what I'm replacing in for that in this particular polynomial. So I'm just going to write out a couple of my terms so far. I'm going to leave my numbers as factorials for a bit, but and you can have ... So I'm going to just simplify a bit. So I have x to the 6th over 2 factorial plus x to the 12th over 4 factorial minus x to the 18th over 6 factorial and x to the 24 factorial dx. Now if I distribute this in, I'm going to have x minus x to the 7th. Now you could write this as a series in series notation and integrate it that way. I'm choosing to do it term by term, but it wouldn't be wrong to do it another way. Okay, so now I distributed the x up. All right, so now I'm going to integrate. Yeah, 1/2 x squared minus x to the 8th over 8 times 2 factorial and x to the 14th, 14 times 4 factorial, x to the 20th, 20 times 6 factorial, x to the 26th factorial. Okay, and then I'm evaluating these at 1 and 0. So just a reminder, I'm doing it accurate to 3 decimal places. That means I want it within 0.001 of what the actual answer is. Okay. So the next thing I'm going to do is plug in 1/2 times 1 squared will be 0.5. Okay, then I'm going to have 1 over 8 times 2 factorial. 2 factorial is 2 times 8 is 16. Next one, I'll have 1 still, not x anymore, and 1 and 4 factorial is 24 times 14. 24 times 14 will be 336. So we're starting to get pretty small, but 1 over 336 is still 0.0029. So we're still at about 3,000. We want to, on this next one, 1 over 6 factorial will be 720 times 20 is 1 over 14,400. That is very, very small, and that is like 0.00006, and that is way smaller than 3 decimal places. So as I'm looking at this, for this approximation, I'm only going to use the first 3 terms here. So I'll have 1/2 minus 1/16 plus 1 over 336. And that comes out as 0.440. Okay, and that is accurate to 3 decimal places. You could evaluate this integral on your graphing calculator to compare that. When you compare it on the graphing calculator, the f int function on the calculator from 0 to 1 x cosine x cubed dx. This is on the calc again. Comes out as 0.440407694. And that's fair, and we are accurate to 3 decimal places. This concludes problem number 43.